October 3rd, 2025. At this very instant, several probes orbiting Mars are directing their lenses toward an anomaly that defies all logic. An entity expelling 150 kilograms of vapor every second without any backward push. It's akin to observing a gun discharge minus the jolt. A breach so basic that experts initially dismissed the readings as faulty equipment. But the gear was functioning perfectly. Avi Loeb from Harvard has scored it a 6 on his extraterrestrial tech meter. Yet that's not drawing you in. What pulled you here is the leak from 2 days back, posted by an alleged European Space Agency insider on 4chan. Packed with specs, depth, and irritation. They outlined an official team that struggled and stumbled to classify this as any ordinary cosmic rock. In their words, this stance can't hold up anymore, and the lack of guidance from the top on handling this mental conflict is turning into a major career headache. They mention reactions that break every chemical rule. Nickel tetracarbonyl, a lab-made chemical from factories, venting from what should be an ancient boulder billions of years in the making. Particles so bizarre that it required a full week of tweaks to confirm the readings weren't bogus. Plus a density riddle. 33 billion tons squeezed into a 3-kilometer span. The probabilities are so slim that either our galactic theories are off by 10,000 times, or this isn't junk from space at all. But what escalates the concern is this. In 26 days, it slips behind the sun, vanishing from sight for the ideal blind spot to every Earth observer. And upon its return in December, we'll discover if its path has shifted. If so, no natural force could account for it. There's a hypothesis, one that echoes pulp novels yet ties up every oddity. The emission sans propulsion, the artificial makeup, the heat-defying norms, a body harboring its own drive system, not fueled by solar rays but by remnants of the universe's birth. And it's verifiable. 2 forecasts, both open to disproof, both due in the coming 3 months. Meet 3I Atlas, our third spotted visitor from beyond the stars, and the initial one prompting astronomers to doubt if it's a mere ice ball or a clever imposter. By the close of this tale, you'll grasp why certain specialists are losing shut-eye, why the flight path seems engineered, why the schedule feels suspiciously spot-on, and the fallout if the evidence keeps bucking trends. Because the barriers are giving way, revealing the true form beneath. If you're game, smash that like and sub now, as this unfolds live. Drop in the comments your location, local time, and the strangest incident you've faced. Chapter 1. The Mars Revelation. Events are unfolding presently. Not next week. Not in a far-off dream where we invent the ideal scope or launch the perfect mission. Today, without delay. October 3rd, 2025. Precisely now, our species boasts various orbiters encircling Mars, each one straining to snap images of the identical target. Dubbed 3I Atlas, it's the third verified wanderer from interstellar space entering our solar turf. And at 4 UTC this morning, it zipped within 29 million kilometers of Mars. That's its nearest brush with any world on this solar tour. The moment matters hugely. Allow me to break it down. Over the last 3 months, ground telescopes have monitored this intruder. Hubble snapped it. The James Webb Space Telescope probed its makeup via spectra. Scores of global facilities followed its drift. But every bit of that intel has a flaw. Range. When Hubble imaged 3I Atlas on July 21st, the thing sat 446 million kilometers out. About triple the Earth-Sun gap. From there, even Hubble's sharp eyes manage limited clarity. Today, though, the game shifted. The Mars Reconnaissance Orbiter, with its high-rise imager, stands 20-fold nearer to 3I Atlas than Hubble managed. 20 times over. The clarity boost is mind-blowing. Where Hubble spotted a hazy smudge amid grit, high-rise ought to pick out traits as fine as 30 kilometers per pixel. Should the body measure up to estimates 5 kilometers across or larger, we might glimpse form, outline, perhaps terrain marks. The European Space Agency's pitching in too. Mars Express and the ExoMars Trace Gas Orbiter have swiveled their gear at the intruder. Mars Express packs the high-res stereo camera. ExoMars features the Cassis for color and depth imaging. Built for Mars terrain, they're now zeroed on this outlier for a fleeting chance. Then come the analyzers. Mars Express sports Omega and Spicum. The Trace Gas Orbiter has Nomad. These tools go beyond snapshots. They dissect wavelengths. In particular, they dissect scientists break down the light bouncing off or coming from an object into its basic color components. This information uncovers the makeup, revealing which compounds are there, the heat levels involved, and whether the changes we're observing stem from ice turning to gas or some other process altogether. The goal, at least according to officials, is for these sightings to clarify some fundamental issues. What's the true scale of the core? Does it spin? If yes, at what speed? How does the surrounding dust haze appear from nearby? And crucially, is this merely an oversized comet acting oddly, or does this thing have some core difference from typical ones? That's the core conflict. Judging solely by its glow, when 3I/Atlas was spotted in July, experts figured it might stretch up to 20 kilometers wide. Later, improved info from the Vera Rubin Observatory shrank that to 10 kilometers. Hubble's late July views pointed to perhaps 5-6 kilometers. Certain calculations, factoring in surface reflectivity, even propose it could be as tiny as 440 m. That's a huge spread, from 20 kilometers to less than 0.5 kilometers. It separates something city-sized from a major structure. The resolution is crucial. Should 3I/Atlas measure 5 kilometers or more for real, it would rank as the heaviest interstellar visitor found yet, dwarfing prior ones by factors of thousands or more. The initial cosmic drifter, Oumuamua, clocked in at about 100 m long, resembling a spinning cigar in the void. The next, 2I/Borisov, reached roughly 600 m and resembled a standard icy wanderer. But 5 kilometers? That's 33 billion tons. Not merely huge, but a real puzzle for the odds. To frame it, today's theories on interstellar ejecta predict that tiny bits should dominate by far. For each boulder the size of a peak hurled from another star system, expect thousands of gravel-like pieces, or even hundreds of thousands. Spotting chances favor the small stuff showing up early due to their sheer numbers. Still, we've logged 3 interstellar intruders to date, and this latest could outweigh the Pioneer by a factor of 1,000 to 1,000,000. That's upside down. Unless our theories miss the mark. Unless space isn't sprinkled with stray junk, but teeming with it. Unless the mechanisms flinging stuff from star systems differ wildly from our assumptions. Or this isn't junk at all. That's what the Mars data aims to probe. If Hera grabs a sharp shot of a 5 kilometers heart, the weight figures stand firm. 33 billion tons sets a solid baseline, forcing us to face the improbability head-on. If it reveals a tinier body, like under a kilometer, the enigma pivots. Such a compact center with the noted shine and gas release implies wild activity, spewing stuff way beyond any comet we know at that solar distance. In any case, the pieces don't fit neatly. Now, the aggravating bit. Answers won't come right away. The info needs sending to our planet. It requires crunching, studying, verifying. The European Space Agency has warned up front that Mars Express and ExoMars Trace Gas Orbiter won't deliver stunning visuals. These probes focus on scanning the red planet below, not peering outward. At 30 million kilometers out, 3I/Atlas will register as barely a dot in their lenses. They could snag the gas envelope encircling it, perhaps a trace of the streamer, but not the central blob. Hydra holds the bigger promise, though even its schedule remains fuzzy. It might take days or weeks for refined pictures to drop. Meanwhile, the visitor presses on. Come mid-October, 3I/Atlas will hug too near the sun for ground views. Solar dazzle will blot it out. It hits perihelion, its sun-closest swing, on October 29th at 1. For Australian dollars, edging just shy of Mars's path. Throughout that mid-October to late-month stretch, it'll lurk sunward from us, concealed and beyond reach. That's 26 days, almost 4 weeks. Upon resurfacing in early December, easing into the morning glow, we'll get another look, track its path, gauge its luster, verify if it acted comet-like near the sun or pulled some surprise. But circling back to now, October 3rd, the Mars highlight. While the main storyline zeroes in on nailing the dimensions, another dimension lingers in this tale. One tied less to fresh shots and more to prior findings. And that's when cracks appear. Chapter 2. The 7 Violations of Natural Order. Avi Loeb dropped a piece on October 3rd, timed right with the Mars pass. In it, He outlined what he terms the 7 oddities of 3I/Atlas. Not mere uncertainties, not just quirks. Peculiar traits, oddities, actions, and features that deviate from the conventional profile of an interstellar comet. He sorted them into 2 groups. The initial group encompasses 4 irregularities that might get resolved or diminished through improved observations. The other group features 3 irregularities that, according to him, will stay enigmatic indefinitely since they don't stem from incomplete data. Instead, they involve odds, paths, and schedules that hint at influences beyond mere coincidence. We'll begin with the initial group, the ones open to clarification. Irregularity 1, dimensions. We mentioned this earlier. The width of 3I Atlas seems to exceed 5 kilometers, resulting in a lowest estimated weight of 33 billion tons. This renders it between 1,000 and 1 million times heavier than the prior 2 interstellar visitors. The potential for explanation depends on whether upcoming scans, such as the Mars past today, validate or adjust that figure. Should the core prove smaller, the issue eases. If verified at 5 kilometers or bigger, the improbability intensifies. Irregularity 2, the stream. Pictures from Hubble reveal a strange element. A forward burst of diffused sunlight stretching 10 times its breadth, aimed straight at the sun. Typical comets exhibit trails that flow away from the sun, propelled by solar winds and radiation forces. Yet this stream bucks the trend. It faces the reverse way. The proposed rationale is that 3I Atlas experienced a strong vapor release on its sun-facing surface, ejecting substances that scatter light prior to reversal. That's reasonable enough. However, the twist lies here. The stream emerged prematurely, at ranges where most comets remain inactive, and it stayed remarkably vivid and enduring. A faint trail did emerge by the end of August, but solely after the body had drawn much nearer to the sun. Such a lag is atypical. It implies the vaporization processes aren't following usual comet patterns. Irregularity 3, material makeup. Here's where it turns truly bizarre. Spectra captured by the James Webb Space Telescope and the Very Large Telescope indicated that the vapor cloud surrounding 3I Atlas holds vastly more nickel than iron. In standard comets, and even the earlier interstellar comet 2I/Borisov, nickel and iron ratios mirror the Sun's, roughly even. Yet 3I Atlas displays overwhelming nickel prevalence. Nickel showed up in all viewing sessions. Iron only surfaced when the object was under 2.64 astronomical units from the Sun. And even so, the nickel-to-iron proportion stayed way above norms. Why is this significant? Nickel and iron qualify as heat-resistant metals. They resist turning from solid to vapor at the chilly conditions on comets. The outer temperature of 3I Atlas, despite proximity to the Sun, remains too frigid for pure nickel to vaporize outright. Another process must be at play. Perhaps a source compound holds the nickel and decomposes to free the atoms, or the warming method defies convention. Regardless, it's baffling. And it doesn't stop there. The vapor mix is atypical too. Most comets brim with water. Nearing the Sun, water frost vaporizes and overwhelms the readings. But 3I Atlas favors carbon dioxide. Its carbon dioxide to water proportion hits 8:1. That's one of the highest on record. It points to origins in an intensely frigid setting, chillier than the zones birthing ordinary solar system comets. Irregularity 4, light reflection. This one's specialized yet crucial. As light bounces from dust specks, it polarizes. The polarization's strength and angle reveal details on those specks' dimensions, forms, and surfaces. All examined comets and asteroids cluster in a foreseen, uniform band. 3I Atlas falls outside it. The polarization results deviated so sharply from projections that the scientists first suspected a glitch. They rechecked the data, identical outcome. To account for the figures, the dust particles must differ at a basic level. Not ordinary silicate grains, not frozen water shards, something novel. Big, intricate bits, extremely spongy, resembling smoke in build. Now, the crux. These 4 irregularities are weird, sure, but they don't outright doom the comet theory. Enhanced info could pinpoint the scale. The stream might represent an uncommon yet organic vapor imbalance. The nickel might derive from a rare source compound we haven't pinpointed. The dust might arise from atypical creation circumstances. Awkward, yet resolvable. That brings us to the second group, the enduring enigmas. Irregularity 5. Path synchronization. 3i Atlas's path matches the ecliptic plane within 5 degrees. The ecliptic forms the planar ring where planets circle the sun. Interstellar arrivals from scattered galactic angles ought to show haphazard tilts. Some orbits tilt steeply, others gently, and a few even loop backward. The odds of any incoming body naturally syncing up so precisely with the solar system's plane? Roughly 0.2%, or 1 in 500. Sure, it's not out of the question. Unlikely things occur all the time. Still, that's our initial warning sign. Next up, anomaly 6, the arrival schedule. Here's where things get truly improbable, plummeting to near zero chances. 3i Atlas didn't merely show up on a path matching the planet's alignment. It timed its entrance perfectly for near misses with Mars, Venus, and Jupiter. To be precise, it'll zip past Mars right now, on October 3rd. A slight tweak could have brought it close to Venus back in July, and it's lined up for a decent flyby of Jupiter come March 2026. For a random interstellar traveler to hit both the right route and the ideal moment for these planetary brushes? Around 0.005%, or 1 in 20,000. Pause and let that sink in. If you were engineering a spacecraft to tour several worlds in a star system, you'd plot a course that crosses their orbits. You'd sync the launch to match their locations. You'd cut down on propellant for any tweaks. That's precisely the blueprint for our own probes, like Voyager or New Horizons, which fine-tune paths and leverage gravity slingshots. 3i Atlas seems engineered for delivery. Chapter 3 dives into the physics-defying quirks. Just 2 days back, a shift occurred. On October 1st, 2025, an unnamed message surfaced on 4chan, not in a scholarly thread, not on AR-14, but on the site's paranormal section, infamous for online myths over solid science chats. Yet this wasn't myth-making. The author purported to be a doctoral-level scientist collaborating with the European Space Agency. They described having direct entry to the merged datasets for 3i Atlas as a member of an official team struggling to decode it and failing. In their words, over months, I've joined a dedicated task force that's repeatedly tried and utterly failed to fit this thing's actions into any recognized category of natural space object. The public stance calls 3i Atlas a highly energetic, yet typical comet. That view's crumbling fast, and the top brass's refusal to address the glaring contradictions is sparking real career headaches for more and more of us. To clarify, 4chan leaks aren't vetted research. They're unconfirmed, potentially pure invention, LARPing, or just a savvy reader fanning flames from public reports. What sets this apart, though? The depth of specifics is standout. The raw irritation rings true, and the assertions mesh eerily with released info while layering in unreported insights. So, I'll unpack their points, not as gospel, but as a peek behind the curtain when data baffles the experts. It kicks off with the venting. 3i Atlas is spewing out about 150 kilograms of gas and dust each second. Hard data, not guesswork. The James Webb Space Telescope captured it, and spectrometers from the Very Large Telescope backed it up. The thing's leaking like a sieve: CO2, water vapor, frozen bits, gritty particles, all in a relentless, furious stream. And per this insider, it yields zilch in response. Their take: it seems like a glitch in the readings until you've triple-checked with every tool at hand, 100 times over. We're detecting roughly 150 kilograms of gas and dust ejecting every second from this body. We witness it happening, but the object? Unaffected. Imagine a cannon blasting around with no kickback, no flash, no roar. It's an ongoing explosive outburst with zero fallout. That's a blatant assault on fundamental physics. Why does this sting so much? Gas expulsion from a comet generates pushback. Action-reaction, per Newton. The fumes blast outward. The core nudges back. It's subtle, granted, but it builds up detectably. Astronomers term it non-gravitational pull, a minor drift from a gravity-only path. All lively comets exhibit it. Think Halley's Comet, Hale-Bopp, or 2I/Borisov, the last interstellar guest. Each showed clear non-grav shifts as they heated up and vented solar near. But 3i Atlas? barely a whisper. A September paper by Richard Kleobevibe and Peter Veverka crunched 4,022 position measurements from 227 global sites, spanning May to September. They mapped the path with pinpoint accuracy, then hunted for offsets, any nudge from the jets. The max they detected? 0.28 arcseconds over months. That translates to under 15 meters per day squared in non-grav force. For something blasting 150 kilograms per second, that's ridiculously faint, practically non-existent. According to the poster's explanation, the object's physics only add up if it's way more massive than it looks. As they put it, the calculations hold only when the thing packs the mass of a miniature moon into a volume spanning no wider than 2 to 3 kilometers. The conservative estimates put a cap at 33 billion tons, which just opens up an even bigger headache. Spotting a mountain-scale boulder hurtling through interstellar space is basically a statistical fluke. Consider the implications. For 3I Atlas to handle the kickback from expelling 150 kilograms per second without budging much, it needs to be extraordinarily dense, beyond ice, past rock, nearing iron levels. Picture a 3-kilometer orb of solid nickel iron. That would weigh about the same. Yet this isn't some metallic space rock. It sports a coma and a tail, venting gases like a classic comet. So the heft is real, but it has to jive with volatile ices coating the exterior. The author goes on. Our observations are barely underway. Encountering something this hefty right out of the gate suggests the galaxy isn't merely sprinkled with junk, it's teeming with it. The predictions are off by 10,000 times. Our whole view of what's flung out from star systems is deeply, horribly mistaken. This thing isn't junk at all. That's the hushed, chilling takeaway we're meant to avoid pondering. Take a beat. Let it settle. If the weight checks out at 33 billion tons or higher, the probability models shatter since big interstellar wanderers ought to be scarce, vanishingly so compared to tiny ones. You expect millions of pebble-sized bits for every mountain-like chunk. But so far, we've spotted 3 interstellar visitors, a slim, disk-like oddity, a fairly standard comet, and now an entity 1,000-fold heavier. The pattern's flipped upside down. We're either absurdly fortunate beyond belief, or the cosmos harbors vastly more hefty drifters than anticipated, by magnitudes, which upends our grasp of how planets form and how stuff gets booted into the void at its core. Or there's the third path. This isn't stray rubble, but wait, it digs deeper. The post claims the composition falls apart too. Examine the gases closely, they say, and it unravels further. We're detecting unadulterated atomic nickel vaporizing away. This occurs at temps where it ought to stay locked in ice. No slow melt like sublimating frost, it's abrupt. The nickel output flips wildly with sunlight exposure. A slight warmth shift, and it stops dead. That points to one thing: decay of a precursor molecule. The sole candidate is nickel tetracarbonyl, a staple in factory purification. Let's unpack nickel tetracarbonyl briefly. It's a formula. Nickel linked to 4 carbon monoxide units. Room temp behavior? A clear, deadly liquid that's quick to evaporate. Uncovered in 1890 by chemist Ludwig Mond. It's key to the Mond process for refining nickel. Start with crude metal, hit it with CO gas under precise setups, form the compound, then warm it to decompose and yield pristine nickel. Purely lab-made or industrial. No natural version on our planet. And per this expert, it's the perfect fit for 3I Atlas's nickel signature. The heat response, the sudden starts and stops, the missing iron. But a comet billions of years old, born in a far-off star system's disk. How does synthetic nickel tetracarbonyl end up there? Nature doesn't brew it. You need targeted setups, pressurized CO meeting nickel metal. And supposing those popped up in some ancient stellar nursery, it's fragile, decomposes easily. It couldn't endure eons adrift unless regenerated on the fly, sparking a weirder puzzle. Generated how? By whom? The discussion then turns to the ejected particles. Its dust is equally bizarre, the post notes. We gauge light bounce to assess particle shape via polarization. Comets and asteroids cluster in predictable bands. This one's readings veer wildly from norms. Our lead pushed us to recheck for days, convinced of errors, until confirmation hit. To match these figures, the grains can't be simple grit or frost. They're huge, wildly intricate bits. Dark, spongy like soot. That's no ordinary powder. It's engineered stuff. The makeup defies logic. The dynamics defy reason. It's a flawlessly coherent art if there's this underlying sense of something off, like the entire thing is designed to make us question our own perceptions. Manufactured material. That's the term they dropped. We already have some open info about the polarization. Back in September, a study came out examining light data from various telescopes. They clocked the polarization level for 3I Atlas at -2. 1% around a 90 degrees phase angle. A negative value there is incredibly uncommon. It indicates the light's polarized at a right angle to the scattering plane, which only occurs with particles that have very particular traits, jagged forms, intricate insides. The study flagged it as odd, but didn't go so far as to label it outright implausible. This supposed insider claims the behind-the-scenes talks pushed deeper. The readings were so wildly off the charts that they first blamed equipment glitches, only confirming the anomaly after redoing the scans with identical outcomes. If those dust particles are big, elaborate, and full of holes, it points to an origin process nothing like what we encounter in typical comets. Comets release dust as ice vaporizes, kicking grains free from the surface. Usually, it's tiny stuff, on the micron scale, straightforward silicate or carbon-based bits. But bulky, hole-riddled ones? That's a whole other story. Almost like the forum post suggests, smoke-like, aerosol bits, superfine substances boasting massive surface-to-volume ratios. You see that from burning, factory operations, or pulverizing solids into ultra-fine dust, not from frost evaporating on a chunk of space rock. The thread goes on about spinning, or more accurately, the absence of it. Hubble Webb spots something that defies logic. A dim, oily streak of a tail aimed right at the sun. Apparently, a huge CO2 burst is blasting from the side facing the star, strong enough to hurl hefty ice chunks that solar rays can't readily shove aside. A fierce, one-way thruster. All right, sure, except it's not tumbling. We've observed it nonstop for days. No shift in brightness. Not even a tiny dip. It's a straight, unchanging plateau. Such a forceful jet on a spinning object would produce a beat, a glimmer, a pattern. Instead, we get total, flawless calm. The tail's rationale calls for a brutal, targeted force. The light data demands a flawlessly even haze. You can't square both. One's fabricated. Either the tail's mechanics are bogus, or that haze isn't organic. It's nuanced, but crucial. If 3I Atlas is twirling and shooting a jet from one spot, we detect recurring light dips as the jet swings in and out of sight, with varying nucleus sections bouncing sunbeams our way. That's routine for comets. Light curves that pulse. 3I Atlas. Nothing. Per this source, the illumination holds steady, rock-solid, utterly level. That suggests just two possibilities. The thing isn't spinning whatsoever, which is almost unthinkable for an object cruising the cosmos for eons. Every bump, every gravity tug adds spin, or the steady glow comes from venting that's totally even, uniform, firing out uniformly everywhere at once. Yet, even venting won't account for the sunward tail. That demands focus, a thrust, and balance. So you've got clashing data points, a tail screaming for a jet, a light profile insisting on balance. They can't coexist unless the encircling dust gas envelope is somehow detached from the spin, or the body is tweaking its surface emissions to lock in even brightness no matter the angle. Nothing about that feels organic. And don't get me started on the heat issue. Then the warmth. This object's frigid. It's soaking up gigawatts of pure solar flux, enough to run a modest town. We run the numbers on the energy flow, and there's a huge excess. That warmth needs an outlet. It ought to be blasting out vast clouds of steam. But the H2O's missing. It's akin to blasting a flamethrower at a snow block and seeing it hold firm. The entity seems to have cracked a method for dumping or controlling a colossal heat burden, holding its exterior at a precise chill. Energy equilibrium, one of physics' bedrock laws. Input matches output, adjusted for storage. For a sunbound comet, inputs solar rays. Outputs infrared glow plus sublimation's hidden heat pull. As ice goes gaseous, it guzzles energy. That's comet's chill trick. Vaporization acts as a thermal sponge. But if 3I Atlas is pulling in gigawatts of sun power without spitting out matching water plumes, What's happening to that energy? This expert says the heat simulations fall apart. There's extra warmth primed to fuel outbursts, but it's not materializing where it should. One potential explanation for the emissions could be a highly reflective surface, with albedo playing a key role. If much of the incoming sunlight bounces back instead of getting soaked up, the overall energy would drop, yet the body ought to shine more brightly than observed. A different idea is that warmth gets channeled deep inside, held within the object's core mass. That would demand exceptional thermal conductivity, rare in icy substances, or perhaps the energy escapes via radiation in unmonitored wavelengths, like infrared or even farther out. Alternatively, the thing might be actively controlling its surface heat, which seems ridiculous, but the observations point that way. Lastly, consider the path it followed. As quoted, and that's prior to examining its route to reach us. The trajectory defies statistical odds. It's an ideal low-angular momentum path, one that ensures a tight sweep. Experts in orbital modeling don't mince words. No natural mechanism sorts large bodies into such routes. This wasn't mere chance. Effectively, the intruder arrived straight from the void. We've covered the ecliptic match and the timed planetary flybys, despite the slim chances. But this low angular momentum piles on more. The path aligns not only with the planets, but proceeds at a leisurely pace relative to usual interstellar velocities. Typical wanderers from other stars race through our system at dozens of kilometers per second. Oumuamua clocked 26 kilometers per second against the Sun's C/2019 Y4 Atlas, hurdles at roughly 60 kilometers per second through interstellar voids. Yet, factoring in solar pull, its nearest pass slows to something approachable, almost crafted to hang around. The piece wraps with a connecting insight. As stated, you're missing the point. These aren't isolated issues. They signal one core malfunction. A thrust strong enough for the tail would cause visible pulsing. It doesn't. Something so hefty should be inert. It's not. Solar warmth ought to scorch it. It remains unaffected. Every contradiction forms a barrier. And here we are, fixated on the barriers, blind to the enclosure's outline. This isn't a flaw in our theories. It's a peek at the gears turning beneath. And those gears are off. A peek at the underlying gears. That wording lingers, implying the oddities aren't glitches, they're intentional traits. The entity isn't faulty. It follows principles beyond our grasp. The insider then proposes a rationale, one echoing speculative tales, yet they insist it's the sole framework fitting the findings. Chapter 4. The Chemical Horror. Now, about the substances venting from this interloper, the composition isn't merely odd. Per the leaked account, it's outright infeasible. The nickel tail begins with heat levels. When the Very Large Telescope aimed its UV spectrograph at C/2019 Y4 Atlas from August through September, it spotted emission lines from nickel atoms. Not bound in compounds, but free atomic nickel shining across the spectrum at each viewing session. The catch? Nickel qualifies as a refractory metal. It melts at 1,455 degrees Celsius and boils at 2,913 degrees Celsius. Music. At C/2019 Y4 Atlas, S orbital range, from 3.1 to 2 Australian dollars and 10 cents out from the Sun, surface temps hover between -100 and -50 degrees Celsius, nowhere near enough to turn solid nickel into gaseous atoms. Still, it's pouring out in detectable amounts. The formal paper treads lightly. Researchers note, detecting nickel and iron atoms in a comet's coma is baffling. At comet observation distances, temps are way too frigid to evaporate silicate, sulfide, or metal particles holding nickel and iron. They propose a precursor molecule, maybe an organic one with nickel that fragments under solar rays, freeing the atoms. But they can't pinpoint it, since nickel rarely yields volatile organics in nature. It's inert, preferring solidity. The purported source dives deeper. They specify nickel tetracarbonyl, and detail why that's profoundly alarming. This organometallic beast features one nickel atom linked to 4 carbon monoxide units. Liquid under standard conditions, supervolatile. It vaporizes at 43 degrees Celsius and, vitally, reacts to light. Hit it with UV, the sun's plentiful output, and it unravels. The CO clusters peel off. Bare nickel atoms emerge. This neatly accounts for the sightings. Surface nickel tetracarbonyl, nudged by faint solar warmth, starts subliming. The gas wafts outward. UV rays strike. Decomposition follows. Nickel shows in the readings. And since the split relies on light, not solely temperature, the output of nickel would be highly responsive to sunlight exposure. Even a minor variation in proximity or orientation could cause a sharp fluctuation in the yield. This aligns precisely with observations from the VT dataset. The rate of nickel generation surges dramatically as 3-2 Atlas draws nearer to the Sun, scaling to the 9th power based on the readings, a pronounced and abrupt correlation. This is precisely the behavior anticipated from a photodissociation mechanism. Thus, the chemical aspects align well. However, the problem arises here. Nickel tetracarbonyl isn't found in natural environments. It's an artificial substance. We produce it in factory environments via the Mond process. You start with pure nickel metal, subject it to carbon monoxide under elevated pressure and controlled heat, and the nickel tetracarbonyl emerges. Next, you transfer it to another vessel and apply further heating. The molecule decomposes, yielding refined nickel. This serves as a purification method, first patented back in 1890. So how does an engineered industrial compound appear on a comet from beyond our solar system? One possibility is that the conditions necessary for nickel tetracarbonyl formation might occur elsewhere in the cosmos. Protoplanetary disks abound with carbon monoxide. Should nickel metal particles be there, and if pressures and temperatures match, perhaps it arises spontaneously. Conceivable, yet improbable. Moreover, even if created, nickel tetracarbonyl proves unstable. It breaks apart gradually, particularly under radiation. An entity voyaging through interstellar voids for eons, constantly hit by cosmic rays, wouldn't retain pristine nickel tetracarbonyl on its exterior, unless it's being generated ongoing by some internal mechanism. That's the claim from the insider, that 3-2 Atlas isn't transporting relic nickel tetracarbonyl from its origins. Instead, it's creating it as a side effect of internal activities. Then consider the iron, or more accurately, its scarcity. In typical comets, nickel and iron coexist. They occur in proportions mirroring solar abundances. About 1 nickel atom per 20 iron atoms. That's the standard cosmic mix. It's what you'd anticipate from matter born in a protoplanetary disk orbiting a star. Yet, 3-2 Atlas displays overwhelming nickel prevalence. Iron only surfaced in spectra when the body was within 2.64 astronomical units. And even so, the nickel-to-iron ratio stayed anomalously elevated, off by a full order of magnitude. What's the reason? If both elements reside in the comet's makeup, why does nickel vaporize readily while iron remains bound? The insider links this to nickel tetracarbonyl. Iron lacks an equivalent volatile counterpart. Iron pentacarbonyl does exist, but it's far less durable and less prone to formation in identical scenarios. Should the venting mechanism favor nickel tetracarbonyl production, you'd observe nickel sans iron. The reactions are discerning. Still, this demands an ongoing chemical operation, beyond mere ice evaporation carrying along metal specks. Something far more intricate chemically. Now, shifting to the dust, since the polarization observations reveal the real oddities. When sunlight bounces off dust grains, it polarizes. The extent and orientation of that polarization hinge on particle dimensions, forms, and makeup. Scientists rely on this for analysis. They gauge the polarization, match it against simulations, and deduce the dust type. All previously examined comets and asteroids fit expected patterns. Silicate grains, icy fragments, carbonaceous bits, they yield comparable polarization profiles. Minor deviations, yes, but always within limits. 3-2 Atlas deviates wildly. From released data, polarization at a 90 degrees phase angle hits -2.1%. Such negative values there are exceptional, exceedingly so. They usually demand grains with wildly uneven shapes or elaborate inner architectures. The leaked account recounts the initial response to the findings. As quoted, "Our director was convinced we'd botched it for nearly a week until we confirmed the outcome. They scrutinized the equipment, readjusted, reobserved, identical results." Per the Post, the sole interpretation for these figures is that the dust particles are utterly atypical. Not ordinary dust, nor the sort released by sublimating ice hoisting surface rocks from a comet. As stated, enormous, highly elaborate grains, dark and spongy like fumes. Ponder the implications. Standard comet dust is tiny, mere microns in size, basic particles. But vast, intricate grains point to alternatives. Clumps, perhaps. Loose assemblies brimming with voids, vast surface areas, minimal mass, reminiscent of soot or fine sprays. That's dust from burning or vapor phase synthesis. Methods that assemble particles molecule by molecule, stratum upon stratum, forging elaborate designs. Not what occurs on an icy wanderer. And dark. Most comet dust reflects decently. It bounces back plenty of light. That's what makes comets observable. But black dew, it soaks up light. It handles heat effectively. It warms rapidly. Should the dust near 3I Atlas be dark and spongy, it could capture sunlight, heat up, and emit infrared radiation. This loops right back to the heat dilemma. Where does all that captured energy end up? The insider's message portrays the odd chemistry as just one piece of a broader puzzle. As quoted, the chemistry is off. The physics is off. It's a completely unified setup of errors, like its entire goal is to make us question our own perceptions. Unified, that's the crucial term. Any single oddity might get brushed off individually. Strange, yet feasible. But combined, they create a framework. A logical image, except it clashes with the idea of a typical comet. It's akin to examining a device where each component is just a bit out of line, yet the device functions anyway. You begin to ponder if the blueprints are flawed or if the device was crafted under alien guidelines. Let me emphasize, the mainstream scientific view, shared by the majority of experts in the field, treats 3I Atlas as a comet. A peculiar one, sure, stretching the limits of prior observations, but nonetheless organic and fitting into planetary science principles. NASA has stated this outright. Tom Statler, NASA's top expert on small solar system objects, informed journalists, it resembles a comet. It acts like one. It closely mirrors in nearly every aspect the comets we're familiar with. And that's accurate. 3I Atlas shows a coma. It displays a tail. It's releasing gases as it nears the sun. Those are classic comet traits. Yet the specifics, the composition, the particles, the heat equilibrium, spark the real debates. The leaked message avoids bold claims. It doesn't assert this is surely extraterrestrial or man-made. Instead, it offers something more unsettling. As stated, for months, I've been involved in an official team that's repeatedly tried and utterly failed to align this thing's actions with any recognized type of natural space object. Utterly failed. Not still investigating. Not more observations needed. Failed. That's the exact choice of words. And should this disclosure be authentic, mirroring true debates in the European Space Agency's team, it means some researchers, upon reviewing the evidence, are quietly conceding they lack a solid explanation. That prompts a big query. If conventional theories fall short, then what fits? From here, the message veers into realms that echo advanced theory or speculative tales, based on your perspective. Chapter 5. The spin that vanishes. All space objects turn. It's inevitable. Impacts add rotation. Gravity tugs introduce twist. Even the mildest stellar brush from eons past sends things spinning across the emptiness. Spinning is the norm. Thus, when stargazers spot a fresh comet or rock, checking the spin rate ranks high on the list. How swiftly does it whirl? They track luminosity shifts over periods. As it spins, various surface areas point toward the viewer. Shadowed areas, lit zones, uneven forms. The glow wavers, mildly or sharply, but it does vary. Known as a light curve. Graph glow against time, and a repeating pattern emerges. The cycle reveals the spin speed. The peaks indicate shape quirks. This ranks among the simplest tools in skywatching. But 3I Atlas lacks it. Per the leak, the body has faced non-stop surveillance. Hubble observed it. Webb followed suit. Earth telescopes monitored it relentlessly, night by night, and the glow remains steady. As noted, we've gazed at it endlessly for days. Its glow stays the same. Not a tiny dip. It's a straight, unchanging line. Absolutely flat. Zero shifts. No pulses, no rhythmic hint. That's not just odd, it's impossible. Even an ideal round body, with any surface differences, slight color variances, or uneven shades, would reveal glow changes during turns. And comets aren't ever flawlessly round. They're bumpy, pitted, scarred. Gas bursts form glowing patches. Particle buildup forms shaded areas. Spin ought to produce a beat, yet 3-eye atlas shows no pulse. One possibility for missing spin signs? If it's turning extremely slowly, a cycle spanning weeks or months, you might miss a complete loop in brief viewing slots. But even so, you'd anticipate slow glow drifts as it gradually pivots. A gradual shift, a pattern, anything. The message calls the glow unwavering, fixed, rigid. So either 3-eye atlas spins not at all, which defies physics for something cruising space over billions of years, or it spins, but the glow ignores the motion somehow, demanding an answer. Now, things start to get tricky. Both Hubble and the Webb telescopes spotted this odd trait. A leading tail, a stream of stuff aimed right at the sun. The obvious answer is a jet stream, a burst of gas from a focused release on the comet's sun-facing side, where the heat hits hardest. Such jets are standard for comets. As ice turns to vapor, it builds up pressure. The gas bursts out via fissures or openings, dragging dust with it into a targeted spray. Yet jets are inherently uneven. They shoot from a single spot in a specific direction. When the body spins, the jet swings around too, now facing us, now turning away, now off to the side. The sunlight it reflects shifts accordingly. This leads to surges, flashes, fluctuations in brightness linked to the spin cycle. Object 3-eye atlas shows what seems like a jet, but without any such light dips or peaks. Those findings clash head-on. The leaked document lays it out starkly. A jet strong enough to form that tail ought to cause the body to blink. It doesn't. Accounting for the tail demands a forceful, one-way outburst. But the light data calls for an even, flawless haze. The two can't coexist. One must be off. Either the tail's mechanism is artificial, or that haze isn't organic. Let's break it down. Assuming the tail is genuine and jet-propelled, we'd expect periodic glints from the activity. But the illumination stays steady. So perhaps the tail stems from something other than a jet, or the light stays steady despite the jet. For starters, maybe the venting is uniform all around, evenly balanced and constant, like a ball gradually vaporizing from every angle. No jets, no lopsidedness. That fits the stable glow, yet it fails to account for the sunward plume. Even release yields a rounded gas envelope and a tail swept rearward by solar winds, not one thrusting ahead. Alternatively, envision a dense shroud of particles around it, so opaque it evens out any light wobbles. The jet could be blasting away, buried in the mist. What we observe is just the smooth outer layer. That might hold up, though it implies huge dust output. Still, the spectrum analysis indicates the gas halo is fairly sparse, not dense enough to block light fully. A further idea, the thing actively controls its shine, keeping a consistent reflecting area no matter the spin or outbursts. It seems far-fetched, but it's the sole way to mesh both datasets without calling one flawed. The source hints this ties into broader oddities. The spin puzzle isn't isolated. It's woven into the same fabric of inconsistencies. The very setup enabling jet-free venting, fake-like reactions, and engineered particle loss. And per the document, that setup runs from within, independent of sun heat or outside triggers. This leads to the thermal anomaly. 3-eye atlas soaks up gigawatts from the sun. No guesswork, it's straight math. Factor in its silhouette size, times the sunlight intensity at that range, and you arrive at the energy intake. For something about 5 kilometers wide, positioned around 2 AU out, that's several gigawatts absorbed. Power for a modest town. That input must exit somehow. Normally, for a comet, it fuels ice evaporation. H2O frost, CO2 solids, assorted ices. Turning solid to vapor gulps up heat in bulk. Comets chill that way. The vaporization acts as a thermal buffer. Input energy, output fumes. Trouble is, the incoming power doesn't align with the outgoing mass. The internal memo reveals the heat tallies don't add up. Our energy balance shows a huge excess. That warmth needs an outlet. It ought to vaporize massive water jets, but the water's scarce. Webb's readings peg the vapors as mainly CO2, a bit of CO. H2O shows up, but way below norms. CO2 to water runs 8:1. That's wildly elevated. Usual comets lean heavy on water. It's the main driver of their behavior, fueling the outbursts. Yet if 3I Atlas gulps gigawatts without venting matching water volumes, what's handling the heat? It could beam it out as infrared. Bodies glow with warmth. The fiercer the heat, the brighter the emission. A surface with strong glow efficiency might shed the load into the void, sparing much ice loss. But here's the hitch. The readings point to a frigid exterior. Exceptionally cold. Much cooler than expected for something bathing in that much solar fire. As the Post puts it, the surface is icy. Like aiming a flamethrower at a snow block and seeing it stay frozen. Thus, the body is taking in gigawatts of power, yet no water vapor escaping and the surface remains frigid. That heat is vanishing. Where's it going? How? The insider's report hints that the entity has developed a method to handle its heat buildup. As stated, the entity has devised a means to either dissipate or control a massive heat burden, maintaining its exterior at a fixed chill. Control. There's that term once more, suggesting deliberate oversight, a mechanism at work, not mere natural heat dissipation, but purposeful handling. Keeping the outer layer artificially cooled demands either a highly effective cooling system or some internal reservoir for heat. An absorber that captures the energy, holds it, or converts it without warming the skin. What occurs like that in the wild? Hardly anything. Definitely not aboard a comet. The experts wrap up, per the leak. The gigawatts from sunlight represent a minor outside factor for a colossal 3-billion-year-old relic equipped with its own energy generator. It sheds solar warmth passively, just like any lifeless stone, since the sun plays no role in its existence. Its built-in generator, an inner motor, produces power from deep within, free from solar influence. And if so, the heat management isn't puzzling. It's an outcome. The entity ignores the sun entirely. It couldn't care less. This leads to the most unsettling inquiry yet. If 3I Atlas possesses an internal energy supply, what exactly is it? Chapter 6, The Cue Ball Idea. The disclosed entry shifts into physics that echoes sci-fi, yet the analyst insists it's the sole lens that aligns the observations. As quoted, it qualifies as a large-scale quantum entity, an enduring, hefty remnant from the initial microseconds post-Big Bang, a vesicle of alternate physical principles that endured, veiled in a layer of our world's rules. In physics theory, this power unit is termed a non-topological soliton. This isn't mere conjecture. It's the singular physical explanation that unifies the findings. A cue ball. Time to unpack that concept. Right after the Big Bang in the nascent cosmos, extremes ruled. Heat and density levels we can't mimic. At such intensities, core forces acted as one. Separate particles now, electrons, quarks, photons, merged in a searing soup. With expansion and cooling, the cosmos hit phase shifts. Symmetries shattered, forces diverged, substances solidified into familiar shapes. Yet these shifts aren't always even. Similar to how freezing water forms voids and spheres, the primordial universe could spawn flaws. Zones where the change didn't finish smoothly. Enclaves clinging to the prior unified form, isolated, enduring. Such flaws get labels: cosmic strings, monopoles, domain walls, and cue balls. A cue ball is a non-topological soliton. Technical speak. Simply put, a self-maintaining wave packet, a clump of energy that stays intact via equilibrium between spreading tendencies and binding nonlinearities. Non-topological indicates no reliance on spatial topology, like a twist. Instead, it's bound by a preserved attribute, a charge. Q denotes charge. Within some models, especially supersymmetric upgrades to the standard model, cue balls emerge. They consist of scalar fields, zero-spin fields. These carry potential energy, and in optimal setups, they form a steady, weighty structure, a sphere where the internal field value differs from the external. The sphere endures because that setup sits at a low-energy sweet spot in the potential map. Crucially, a cue ball powers itself. The inner field degrades gradually, emitting energy across ions. That output appears as particles, emissions, warmth. The cue ball sheds mass bit by bit, but so leisurely that one born in the universe's dawn could linger now. Admittedly, this ventures into unproven territory. Cue balls remain unseen. Theories foresee them, but those frameworks lack proof. Many experts view them as intriguing possibilities, cosmic entities that could be out there, though unlikely. But the leaker asserts 3i Atlas matches the blueprint. Spot on. Let's trace the reasoning. Suppose 3i Atlas is a cue ball. What signs would appear? Start with huge mass packed tightly. Cue ball's pack density. The core field concentrates intensely. A 3 km cue ball might carry small moon heft, around 33 billion tons. That aligns with the baseline mass figure from absent non-grav poles. Next, even outgassing all around. The cue ball's breakdown occurs centrally. Energy bursts outward symmetrically. It warms the encasing layer, a sheath of gathered frost and grit, from inward. That frost turns to gas in a balanced pattern. No propulsion, no jets, no directional push. The gas release is evenly distributed all around. Zero overall pushback. This accounts for the howitzer-style launch without any recoil. The intense venting with absolutely no repercussions. Inside, the decay mechanism generates the fumes. They disperse uniformly in every direction. Newton's third law holds true. The force and counterforce neutralize each other. Next, steady illumination. With isotropic venting, the haze of particles and vapors encircling the cue ball forms a perfectly round envelope. Spinning has no effect. The thing appears identical no matter the viewpoint. The glow stays constant since nothing uneven is turning. Then, unusual reactions. A cue ball's breakdown ignores standard heat laws. It's rooted in particle physics, intense and energetic, able to form bizarre substances. That gradual energy converter, dubbed the slow burn reactor in the article, runs at a stable cool level. Yet it's no ordinary heater. It's a quantum breakdown phenomenon. Across eons, it yields leftovers, intricate structures, carbon-metal hybrids, engineered particles, the remnants of a primordial motor. Also, heat neutrality. The cue ball ignores solar warmth entirely. Its core power source overwhelms any external heat from the star. Surface temps are controlled not through soaking up and re-emitting sunlight, but via the consistent emission from within. The billions of watts from the sun amount to a minor outside factor. Onto the path. If cue balls abound as dark matter pieces, the galaxy teems with them. They're ordinary, not oddities scattered sporadically. 3-2 Atlas isn't junk flung from some far-off sun. It belongs to the basic makeup, a leftover from the universe's birth. That clarifies spotting an object this hefty so soon. We're not eyeing cast-off world fragments. We're confronting dark matter directly. The article presents this as a breakthrough. It states, the cue ball embodies the mass. Its power comes from its own erosion. The absent recoil is no riddle anymore. It's a core trait. The venting isn't a stream. It's uniform erosion, an ideal round dispersal of material. As the nucleus heats its shell outward from the center, no overall force emerges. It travels without fallout in a flawlessly even setup. And further, this isn't faith-based. It's the soul physics fitting the observations. View it that way, and the whole mess of inconsistencies forms a coherent, chilling vista. Chilling. That's the term chosen. Not fascinating or unexpected. Chilling. The reason? If 3-2 Atlas is a cue ball, dark matter isn't some unseen, lifeless junk strewn across the void. It's dynamic. It's substantial. And it's ubiquitous. The galaxy isn't sprinkled with occasional space boulders. It's crawling with primordial giants. Every one a Big Bang survivor. Every one eroding gradually. Every one prone to drifting into a star system and causing what? Harmless passage or far graver issues. But the key here, the cue ball idea can be verified. The piece closes with forecasts, concrete, checkable statements. It says, commit this to memory. Initial forecast, behavior unaffected by sun proximity. Typical comets react to stellar heat. As they pull away from the sun, their action dims, venting eases, shine wanes. This holds for all. Each comet tracked shows this. Yet if 3-2 Atlas runs on an inner drive, it defies that norm. Even as it heads to the system's fringes beyond 3AU, beyond 4, its glow and shedding pace ought to stay anomalously strong. It bucks the cooling norms for inert objects. That's verifiable. We can monitor. Come December, after it slips behind the sun, we'll get extended views as it retreats. Should it keep shining? Should the venting persist full force? That's definitive proof. Comets never behave so. Secondary forecast. Intense radiation output. The cue ball's erosion is a subatomic occurrence. Roughly 73 megawatts per the article's calculation. That power doesn't disappear. It spawns rays, energetic ones, gamma bursts, X-rays, a non-heat signature ripe for detection. It notes, aim a gamma ray scope its way. Spot a signature not from solar wind clashes, and it's no comet. You're sensing the pulse of something defying normal physics. That's verifiable too. Gamma ray detectors are out there, like Fermi or Integral. If a potent source aligns with 3-2 Atlas's spot, we can pinpoint it. Comets don't spew gamma from their guts. Only wild cosmic beasts do. Pulsars, black holes, blast leftovers. Or, per the theory, cue balls. To state it plainly, this isn't standard astronomy. Cue balls remain hypothetical, fringe concepts. Most experts in the stars would reject this outright. It's outlandish. It demands embracing that dark matter it adopts a shape we've yet to encounter before. The notion that the primordial cosmos generated enduring large-scale quantum entities. That one such entity is currently traversing our solar neighborhood. The more straightforward account suggests that 3I/Atlas is merely an odd comet, featuring bizarre composition, peculiar particles, perhaps a paired core or some inner configuration beyond our current grasp, yet entirely natural and accountable through standard astronomical principles. This view represents the consensus among experts, and it could well prove accurate. However, should that purported internal memo be authentic, if a European Space Agency team is indeed grappling to reconcile the findings, then the CQ sphere theory is under hushed consideration in private sessions, not as the definitive solution, but as the sole option that avoids dismissing a substantial portion of the evidence. And should the forecasts pan out, should 3I/Atlas maintain its luminosity on departure, should gamma emissions appear, the discourse shifts dramatically. Chapter 7. The Concealed Adjustment Phase. In 26 days, 3I/Atlas will execute a move that ought to unsettle observers. It will fade from sight, not vanish entirely. The entity persists, continuing its path. Yet from our planet's vantage, it becomes undetectable, eclipsed by the sun's intense radiance, engulfed in our star's overwhelming light. This occurs on October 24th, as the object enters solar conjunction. Our world, the sun, and 3I/Atlas align linearly, with the sun positioned centrally. From then through the start of December, observation proves impossible, no monitoring of its location, intensity, or composition. For almost 6 weeks, the body slips from detection. And precisely on October 29th, smack in the heart of this observational void, 3I/Atlas attains perihelion, its minimal distance to the sun, at 1. For Australian dollars, slightly inward from Mars' path. This coincides with peak solar influence, the juncture where a typical comet ramps up activity, where vapor release surges. We'll witness none of it. Such alignment hasn't escaped attention. Avi addressed it directly in his October 3rd piece. At its perihelion on October 29th, 2025, when it hits 1.35 Australian dollars from the sun, 3I/Atlas will lie completely screened from Earth by the sun. Assuming this screening falls within a solar elongation of 30 degrees, it's easy to compute the odds of this Sun-Earth alignment at about 7%. A 7% probability. Improbable, yet far from sheer luck. Roughly 1 in 14. This is where unease creeps in. Should 3I/Atlas function as a probe, equipped with drive systems capable of course corrections, perihelion emerges as the prime opportunity for action. In particular, to execute a reverse Oberth burn. Allow me to clarify. The Oberth principle governs orbital dynamics. When igniting engines, the boost in kinetic energy hinges not only on the impulse, but also on prevailing speed. Activate propulsion at high velocity, and efficiency soars. The energy increment maximizes. Probes leverage this routinely. To break free from a world or sun, apply force at periapsis, the nearest point, where speed peaks. That's the classic Oberth burn, peak performance. A reverse orbit burn flips the script. You're hurtling along a hyperbolic arc, exiting the system, but desire retention. You aim for gravitational capture. Thus, at perihelion, maximum speed, you engage thrusters to decelerate. The speed drop proves most effective there. You shed energy, altering the path from hyperbolic to elliptical. Rather than fleeing, you settle into orbit. For 3I/Atlas to linger within the solar system, October 29th marks the ideal instant to alter course, and it unfolds concealed behind the sun, shielded from terrestrial eyes, beyond scrutiny. Loeb presents this judiciously. He avoids asserting inevitability. He highlights the advantageous setup. From his write-up, this might be deliberate, to evade in-depth scrutiny from ground telescopes during peak illumination or when devices deploy toward Earth from that screen position. The prime spot for a reverse solar orbit burn to achieve solar binding lies at perihelion. It's exactly this prime deceleration phase for 3I/Atlas that's blocked from sight by the sun. Devices, that's his term, compact probes dispatched from the primary body, exploiting the backward path and near-planetary flybys to contact Mars, Venus, or Jupiter using scant propellant. The math supports it. In Loeb's July study alongside Adam Hibbs and Adam Crowell, they detailed the delta V needs. Delta V denotes the velocity shift required to hit a destination. For 3I/Atlas to launch a probe toward Mars in early October, the delta V stays under 5 kilometers per second. That's on par with an ICBM, feasible via chemical rockets. Venus follows suit, under 5 kilometers per second into July. Jupiter holds below 5 kilometers per second past November. EA returning to Earth would demand even greater speeds, exceeding 5 kilometers per second, which ramps up the energy demands significantly. For anyone planning a scouting mission, that could be why our planet gets bypassed on the first sweep. Swing by the other worlds initially, collect intel, and only then figure out if Earth's worth the extra burn. Keep in mind, this remains purely speculative. Lowe isn't claiming it's actually occurring. He's just pointing out that the path and schedule might permit such a strategy. The crucial point here is that certainty won't arrive until December. As 3Atlas swings back into view from solar occultation in early December, it'll show up low in the eastern pre-dawn sky, dim but visible to keen eyes. Astronomers' immediate move will be to pinpoint its location, compute the orbit anew, and verify any shifts. Should the path match forecasts precisely, with the body right where gravity alone would place it, then all is routine. It rounded perihelion, vented gases perhaps, and pressed onward. An odd comet, sure, but nothing extraordinary. On the other hand, any orbital tweak, no matter how minor, signals an event during that hidden phase. Maybe it adjusted course, broke apart, or encountered something that nudged its route, and that would shake things up. Lowe pinpoints a narrow detection period, November 21st through December 5th. Pulling from his prior blog entry, the researchers emphasize their idea can be tested and potentially disproved. If 3Atlas threads the solar system sans any odd adjustments, especially in that November 21st to December 5th, 2025 slot, the notion gets tossed. Just 2 weeks of intense scrutiny. Any tweaks at closest solar approach would reveal themselves as path wobbles by late November. The pros will be glued to their scopes. Yet there's more depth to unpack. The idea of an advanced scout. Back in September, Lowe dropped fresh math. Suppose 3Atlas dispatched a compact probe earlier on, one forging ahead by roughly 30 million kilometers. That timing lines up for a Mars encounter this week, October 3rd, aligning with the flyby date. The numbers add up. Such a device wouldn't require much size, a handful of meters, say 10 across, like a compact vehicle. At Mars range, reflecting sunlight that faintly, it'd evade ground telescopes entirely. We might miss it from here, though it could lurk undetected. The high-rise instrument aboard Mars Reconnaissance Orbiter isn't solely targeting the primary body. Per Lowe's advice, it ought to sweep the inbound lane for tinier intruders, forerunners, or sentinels. Did NASA prioritize that? No public word on the fine print of their imaging schedule, but it's feasible they did. Spot an anomalous speck in the feeds, compact and unforeseen, and the whole discussion pivots overnight. Still, the prevailing view, what most experts anticipate, involves zero drama. 3 Atlas grazes perihelion, heads outward, and dims away. A quirky comet, fascinating to probe, yet merely one more wanderer from beyond. No course corrections, no offshoots, no veers. That's the default outlook, and odds favor it holding true. But the setup feels off-kilter. The schedule raises eyebrows. That pivotal stretch occurs precisely when visibility vanishes. That's the prickly bit. Toss in the cue ball concept, and unease amplifies, since a cue ball skips engines altogether. No steering needed. It's static yet enormous. A whopping 33 billion tons. Grazing a world up close lets it pull gravitationally. A planet's path might waver subtly, though trackably in the long run. Mars draws the spotlight. 3 Atlas zips within 29 million kilometers right now. Near enough. No smash-up risk, but sufficient for tidal tugs to register. Were the mass figures accurate, Mars ought to register a faint yank. Its orbital specs, the exact metrics charting its solar loop, might budge just enough to notice. Skywatchers monitor Mars nonstop, with positional data razor-sharp. Even a modest gravitational ripple from 3 Atlas would register, not right away, but as weeks and months unfold, with Mars plodding along, the offset builds. Another checkpoint, a fresh angle to validate or dismiss the bulk estimates, with findings trickling in across the coming months. Thus, we hold our breath. October slips by, the thing conceals itself, November kicks off renewed scans, and come December, clarity emerges. Course tweak? Path alteration? True heft? Revelations loom, prepared or otherwise. Chapter 8 dives into the diversion ploy. Nested speculation within speculation, and perhaps the most disquieting variant so far. Imagine if 3 Atlas serves as a smokescreen? The notion stems from Omar Dadai, a teammate of Avi Lowe's. He floated that a sophisticated society could deploy a comet mimicking the natural interstellar sort as bait, something vivid, something glaringly conspicuous. It's the kind of thing that pulls in observatories and spotlights alike. Or perhaps the genuine mission unfolds somewhere else entirely. Avi Loeb explored this idea in his August blog entry. He wrote, "My colleague Omar Ladyardi proposed that extraterrestrials could employ a natural interstellar comet as a distraction, drawing our focus while they carry out a separate maneuver closer to our planet. From that viewpoint, it would be worthwhile to examine if there's a spike in unidentified anomalous phenomena within Earth's skies following the Comet 3I/Atlas's nearest pass by the Sun on October 31st, 2025. A surge in UAP events near the moment 3I/Atlas hits perihelion. That's something we can verify, and folks are already on the case. The Galileo project, under Loeb's guidance, forms an astronomical effort aimed at detecting signs of alien tech, not via radio waves or far-off worlds, but right here in our vicinity, deploying scopes and detectors to scan the heavens for oddities. It operates 3 sites, one at Harvard College Observatory in Massachusetts, another in Pennsylvania, and a third in Nevada, all fitted with imaging gear, heat-sensing tools, radar setups, and sound capture devices. They sweep the full dome overhead nonstop, logging every bit of motion up there. AI sifts through the feeds, sorting items like birds, aircraft, orbiting satellites, UAVs, or shooting stars. The bulk turns out ordinary, straightforward to account for. Yet now and then, an anomaly pops up that defies explanation, an item zipping along at odd speeds, lingering too long, or veering in patterns no standard flyer could manage. Those get marked for deeper review and scrutiny. Launched in late 2022, the Galileo project has gathered intel on over 500,000 skyward entities. Nearly all get pinned down and rationalized. No real oddities so far, but the network keeps vigilant. And per Loeb, it'll stay extra alert come October and November. As he noted, fortunately, the Galileo project, which I direct, will keep tabs on the skies via its 3 facilities in Massachusetts, Pennsylvania, and Nevada throughout that stretch. So should UAP sightings ramp up, or bizarre presences emerge in our airspace as 3I/Atlas lingers sunward, the setup ought to snag them. A link in timing, a match in patterns, that'd spark real curiosity. To clarify, Loeb isn't forecasting visits from alien vessels, nor is he claiming 3I/Atlas serves as a surefire ruse. Rather, he's urging a scan for follow-on actions if it were such a ploy, and his group stands ready. The distraction theory builds on certain premises. For starters, that 3I/Atlas is either engineered or guided. Next, its goal involves scouting, not overt outreach. Finally, its senders, or operators, seek to divert human gaze toward the glaring standout, letting subtler, sneakier efforts unfold nearer to us. What might prompt a superior society to play it this way? For one, leveling the intel playing field. When probing a possibly aggressive or erratic race, you avoid fanfare. Instead, you collect insights discreetly, launching tiny scouts with minimal detectability, all while steering the mark's scrutiny elsewhere. 3I/Atlas grabs eyes, vivid, standout, peculiar. Telescopes worldwide and in space have trained on it. Studies emerge, experts argue, news outlets hype the show. Meanwhile, with all heads craned skyward at the comet, what's stirring in our air layers or orbital paths? Tiny, hushed intruders, pulling off feats we might overlook? The Galileo project's records could reveal it, or at minimum, flag a rise, a data outlier, extra puzzles defying norms, bunching up in late October through early November. Such a pattern wouldn't confirm the ruse idea. Links don't equal causes, but it'd demand attention. Then there's the notion of covert, blended vessels, floated by Gabber, a follower of Loeb's writings. The concept suggests a sophisticated society wouldn't craft ships from the ground up. They'd repurpose raw stuff, rocks from space, icy wanderers, reshape them, carve out cores, embed tech within, leveraging the organic shell for cover. Loeb cited Gabber in his post. We're gearing up for asteroid harvesting ops ourselves, so for a far more capable group, this might be routine. A stony shell delivers top-notch innate protection. The thing blends in naturally. Without emissions or man-made shine, it passes as a plain old space boulder from afar. This tackles a key hurdle. To dispatch anything across stars, you require barriers against cosmic radiation, charged bits, tiny impacts. The void between systems is brutal. Forging dense armor adds mass and cost. But grab a boulder to begin with, and the armor's already there. Hollow it, fit in your gear, and launch. Outwardly, it mimics a comet. It emits gases. It sports a tail. It acts like any ordinary comet, yet beneath its surface lurk mechanisms, devices, energy supplies, perhaps even a hibernating team in stasis, biding their time. This notion isn't some fresh theory. It's been a staple in science fiction for ages. Think of Arthur C. Clarke's Rendezvous with Rama, that enormous tube-shaped vessel masquerading as an asteroid. Or Greg Bear's Forge of God, where replicating bots conceal themselves within icy wanderers. The idea feels commonplace, but it's also cleverly efficient. When traversing the voids between stars, enduring eons en route, leveraging cosmic debris just makes logical sense. It complicates spotting by observers who chalk up such bodies to mere space junk. Without blatant unnatural maneuvers, they're pegged as ordinary. 3I/Atlas hasn't pulled any such stunts. No broadcasts, no trajectory tweaks, no engineered glows. It simply doesn't align perfectly with the observations. The compositions ask you. The mechanics don't add up, the path raises eyebrows, yet nothing conclusive emerges. That's the genius of a covert blended craft. It's plausible to dismiss, open to interpretation. You need proximity, real proximity, to confirm artificial origins. And by the moment a probe could catch up, the thing's vanished. Thus, we're stuck pondering. Might the Galileo initiative spot oddities in the near future? Could UAP sightings spike? Will oddballs appear that defy categories? And should that happen, will folks link them back to 3I/Atlas? Or will October and November slip by uneventfully? No oddities, no surge, just a wanderer dipping behind the sun and popping out opposite. Peculiar, sure, but in the end, just another rock. The evidence will settle it eventually. All we can do is hold out a bit longer. Chapter 9. The Protocol of Quietude. The research world is splitting over this enigma. Not in public forums or formal declarations, but in subtler venues, the threaded emails, the sidebar chats at meetings, the after-hours debates in labs. Two factions have formed, and the rift is growing. One group insists 3I/Atlas is a comet through and through. Quirky, boundary testing, but firmly in nature's domain. The odd makeup? Chalk it up to undiscovered precursor compounds. Density figures? Likely flawed. Fresh observations will sort it out. Patience and methodical inquiry will iron out the quirks. The opposing view harbors more doubt. They pore over identical datasets. They crunch parallel numbers. Yet their conclusions clash, not merely on fringes, but right at the heart. The laws of nature falter unless you embrace assumptions that border on absurd. Immense compactness, hidden power cores, engineered compounds. That anonymous 4chan leak captures this schism. The stance from on high labels 3i/Atlas as an exceptionally lively, yet natural comet. That view no longer holds water, and the leadership's hush on the mental strain this demands is turning into a major career hurdle for more and more of us. Mental strain, potent wording. It describes juggling clashing convictions at once. Here, it's trusting the readings while insisting on a natural origin. Accurate inputs mean no natural fit, but a natural label demands faulty inputs. Yet those inputs have faced scrutiny from diverse squads, via varied tools and techniques, and they consistently hold firm. So what becomes of the scientists grappling with the mismatch? The leak suggests they're being nudged away from unconventional takes. Not outright banned or silenced, merely steered. The rewards of academia favor standard narratives. Manuscripts floating bold ideas draw tougher critiques. Funding bids dropping words like artificial or unnatural meet raised brows. Reputations can grind to a halt. This pattern isn't exclusive to 3i/Atlas. It's a systemic snag in academia, the urge to cling to established paradigms, avoid stirring trouble, temper bold assertions. Usually, this safeguards progress, curbing baseless rants from overshadowing sound research. But sometimes it fosters oversights, spots where evidence veers one direction while the field stares elsewhere. Jason Wright, a Penn State astronomer, has spoken out sharply on this. He's taken aim at Avi Loeb's handling of 3i/Atlas, much like his past jabs at Oumuamua. Wright contends Loeb leaps too hastily to extraterrestrial notions, overlooks straightforward data points, and hypes assertions that crumble under examination. In a blog entry, Wright noted, Avi has built a name for proposing, or flat-out declaring, that various things might be alien probes, even absent compelling evidence. He adds that Loeb wasted no time dubbing 3i/Atlas an interstellar artifact. Wright then dissects particular arguments. The notion that telescope views of an elongated shape stem from mere blurring? Wright counters that today's scopes adjust for target shifts. They follow. They layer exposures. Images from Mars aren't plagued by streaking in pro setups like observatory gear. When several separate sightings confirm an elongated object, it's legit. Comet Atlas sports a fuzzy envelope, sealing its comet status. Yet Avi Loeb's take is subtler than what Wright's rebuttal implies. Loeb avoids absolute claims. Instead, he's suggesting a spectrum, a structured approach. Picture the Loeb scale from 0 to 10 o'clock means purely natural for sure. 10 screams artificial without doubt. He pegs Comet Atlas at a 6. Nothing set in stone, no proof locked in, but significant enough to demand thorough scrutiny. That scale stands out on its own. It shifts the debate from yes or no aliens to degrees of oddity. Not just is it extraterrestrial, but how unusual is it? How far off the norm? And what oddness level sparks which actions? Loeb advocates for this scale to get official backing from a global entity, namely the United Nations. Back in October, a position paper dropped, penned by Omar Diaz, Gershon Tenenbaum, and Avi Loeb, called Advancing Interstellar Science, a global framework for comprehensive study of interstellar objects. It calls for launching UNCIO, the United Nations Committee on Interstellar Objects. The concept is simple enough. With tech advancing, especially as the Vera C. Rubin Observatory ramps up, we'll spot way more interstellar visitors, potentially one every couple of months or even oftener. Projections back that up. These are brief shots at insight. They zip by fast. To probe them properly, we'd need unified efforts, worldwide, swift, and mapped out ahead. UNCIDO could unify procedures, set guidelines, link up observatories with reserved slots, keep quick launch probes on standby for immediate deployment, and most importantly, roll out the Loeb scale as the go-to rating tool. Anything scoring 4 or better gets boosted monitoring. A 6 would flag the UN Security Council. Scores of 8 plus kick in urgent measures. Comet Atlas is holding at 6 right now. Should it alter course, if gamma emissions pop up, or if the outbursts ignore sun proximity, the score climbs, and global actions ramp up in tandem. This plan is bold. It demands cash, diplomatic buy-in, and teamwork among space outfits. No sure bets there, but the blueprint exists, and U.S. Representative Anna Paulina Luna has thrown her weight behind it. Her backing letter even makes the paper. UNCIO's fate hinges on events in the coming months. Should Comet Atlas just dim and drift off, the push loses steam. It turns into a quirky case, an oddball comet good for a journal article, but no panic. If developments twist, if the thing acts inexplicably, the tone changes fast, and global sinking stops feeling like red tape. It starts seeming essential. Another factor here is openness, or rather its absence. That 4chan thread alludes to behind-scenes talks kept under wraps, unreleased findings, bottled-up gripes. If accurate, if private chats among experts diverge from public lines, that divide will bridge eventually, via drips or official reveals. Science thrives on candor. Share the datasets. Test ideas out in the open. Keep reviews straightforward. When that falters, when info gets compartmentalized or reined in, faith crumbles, and guesses rush the empty space. We're stuck in this odd limbo at present. Plenty of info's out there to stir doubts, but short on closure. Key looks, like Mars PASB shots, gamma hunts, December path data, remain in the works. And amid that void, folks are tuned in, on edge. Telescopes for some, wild ideas for others, and a handful supposedly sitting on forbidden intel. The story's next turn won't come from hunches. It'll stem from hard evidence, sightings, readings that either back the standard view or nudge us toward other possibilities. Things are heating up. The Mars close-up went down today. Perihelions, 3 weeks off. December's reappearance looms in 2 months. Come year's close, we'll have fresh intel. Not the full picture maybe, but progress. Should the weirdness linger, should facts keep defying norms, then any hush rules, whatever their shape, won't last. In time, the barriers around tough queries give way, and the truth's outline sharpens, ready or not. Chapter 10. What's on deck? Mars imagery ought to land in days, perhaps a week tops. The Mars Reconnaissance Orbiter's beamed its hull home. Techs are crunching it, fine-tuning, sharpening. Before long, we'll glimpse what high-rise snagged during the close approach. Everything hinges on spotting the core. Should the nucleus stand out clearly, measuring 5 kilometers across or more, the implications grow more compelling. Dismissing a mass of 33 billion tons gets tougher. The odds of encountering an object that enormous turn into an undeniable outlier. Interstellar space might be a lot busier than expected, or this visitor stands apart in puzzling ways we haven't grasped yet. Conversely, if the nucleus measures under a kilometer, the enigma pivots sharply. A tiny core generating such intense gas releases, maintaining that level of luminosity so far out, points to a whole new challenge. It hints at unusual vigor, perhaps residual warmth inside, or forces fueling the ejections well beyond basic sun-heated evaporation. Whichever result emerges, it sparks fresh inquiries without settling the old ones. Observations from the Mars Express and ExoMars Trace Gas Orbiter will pile on more details. Positioned for a nearer view, their tools focus on air-like studies, probing the vapor makeup from an alternate perspective, spotting molecules invisible to ground telescopes, or uncovering even odder chemical signatures in detail, could shift the narrative. Meanwhile, tracking the glow keeps ramping up. With 3i/Atlas pulling farther from Mars and heading to its sun-skimming low point, Earth watchers face a shrinking opportunity. By mid-October, it vanishes into the sun's blinding halo. In the interim, each evening's light measurements, every spectral scan, and all polarization checks matter hugely. Global teams gather this info, store it systematically, and construct a chronological record. Come December's return from behind the sun, that record turns pivotal. We'll juxtapose the inbound patterns against the outbound ones. Does the surge align with forecasts, or does it stray? Typical comets obey a scaling rule. Illumination and vapor output climb as the reciprocal of the sun's distance squared, sometimes more aggressively. Nearing the star, things heat up. Pulling away, they cool off. Reliable, across the board. If 3i/Atlas bucks this trend, holding strong output beyond 3 AU or 4, alarms blare. The earlier CUB forecast banks on exactly that. A built-in power source ignores solar proximity, it's steady regardless. This claim invites direct testing, easy to refute. Clarity arrives by January or February. The gamma-ray hunt weaves in another angle. Facilities like Fermi and Integral sweep the heavens non-stop for energetic light bursts. Any internuclear reactions or breakdown events in 3i/Atlas yielding zippy particles ought to ping those detectors. Nothing official on gamma emissions from 3i/Atlas so far. That said, scans could be underway without fanfare. Processing raw feeds demands time. Bursts are subtle, swamped by cosmic static. A find might stay under wraps at first, or lurk undiscovered in archives. Should gamma rays show up, tied to the object's spot, and defying explanations from sun-wind clashes or stray cosmic hits, it's revolutionary. Everyday comets don't spew gamma rays from their guts. Only powerhouse cosmic phenomena do: pulsars, magnetars, exploding stars, or maybe bizarre substances. Mars' orbital wobbles offer a subtler clue, unfolding gradually. We monitor the red planet with pinpoint accuracy, its path charted down to meters. A tug from 3i/Atlas during the near miss would nudge it faintly from expectations. Barely noticeable at first, millimeters daily, but compounding over time. Into early 2026, any true offset becomes quantifiable. And if it lines up with the gravitational nudge from 33 billion tons, that's standalone proof of the heft, bypassing any vapor analysis, relying solely on pull. The Galileo project's UAP watch via its stations runs in real time. Streams pour in continuously. A surge in odd sky events syncing with the sungray's peak would pop in the numbers. Extra sightings, bizarre paths, timed bunches. No uptick wouldn't kill the decoy idea. It'd just trim one prop. But a clear cluster, focused around late October to early November before fading, demands attention. Fast forward to December 5th, closing Eloise deadline for spotting path shifts. A mid-sun maneuver by 3i/Atlas, like a braking thrust to lock into solar orbit, should reveal itself by then. Telescopes will log its whereabouts, compute the trajectory against models. An unaltered path means pure gravity ruled, no artificial tweak. It sailed through naturally and departs. Enigma intact, but outbound. A altered course, unexplained by gas jets or breakups, signals action hidden sunward, invisible to us, begging for answers. The Vera C. Rubin Observatory throws in one last curve. Kicking off this year, it runs wide-field sweeps, probing depths with auto-alerts. Built to uncover ancient artifacts, drifting entities, space rocks, icy wanderers, and visitors from beyond our solar system. Projections suggest that Rubin will spot one interstellar interloper every couple of months, possibly even more frequently. In just 1 or 2 years, we could amass dozens of them, turning each into a valuable benchmark for analysis. Does 3Atlas stand out as a one-of-a-kind wonder, or is it merely a member of a broader group? Should upcoming interstellar arrivals display comparable oddities, like immense density, bizarre compositions, steady luminosity, then 3Atlas wouldn't be an anomaly. It would serve as a harbinger, our initial glimpse into a galactic commonplace we've only recently begun to recognize. On the other hand, if those future finds turn out to be typical, modest in size, orderly icy bodies, 3Atlas would remain solitary, an enigma that deepens rather than diminishes its intrigue. The broader context boils down to this: we're standing at a pivotal moment. For the very first time, our technology allows us to examine these cosmic travelers thoroughly. Beyond mere identification, we can probe them with spectroscopy, sharp detailed photography, swift deployment operations, and global teamwork. 3Atlas acts as a rigorous trial run. It's challenging every tool, every simulation, every preconception we hold. Through this pressure, it's exposing weaknesses, areas where our knowledge proves shallower than anticipated. Certain of those voids will narrow. Enhanced observations, polished hypotheses, overlooked mundane causes. Science excels at unraveling puzzles. not instantaneously, but in due course. Yet some voids could expand instead, evolving into vast divides, shifting the discourse entirely from "what sort of comet" to "what exactly is this?" We haven't crossed that threshold, but we're near enough to glimpse the brink. The coming 3 months hold key insights: snapshots from Mars, the closest solar approach, hunts for gamma emissions, its reappearance in December, path calculations, reports on unidentified aerial phenomena. Every fragment builds the mosaic or adds fresh layers of complexity. Come March, as 3 Atlas swings by Jupiter and the Juno probe takes its turn observing, we'll possess a sharper view. Not flawless, but improved. Should the enigma persist by then, lingering at a 6 or above on the anomaly meter, the hush order crumbles. Inquiries grow too insistent, evidence too insistent, forcing us to grapple with the 4chan insider's claim. This isn't a flaw in our frameworks. It's a peek beneath them, a hint at an underlying reality we were oblivious to. Whatever form that reality takes, whether exotic particles, unconventional stellar physics, shadowy substances, forgotten artifacts, or utterly novel, discovery looms. The cosmos operates on its own timetable. It neither hastens nor conceals. If 3 Atlas harbors a hidden truth, if mechanisms lurk beneath its exterior, they'll emerge via the influx of measurements, the vigilant watch, the gradual buildup of proof that either validates or refutes. Our role is to observe patiently, remain open to the trail of clues, no matter how unsettling the destination. After all, science isn't a collection of solutions. It's a process for posing sharper inquiries. And 3 Atlas poses one of the most compelling in ages. What exactly are you? Thus, we arrive at the close of a tale still unfolding. October 3rd, 2025. The Mars encounter wrapped up mere hours back. Information flows in steadily, and amid it all might lie a resolution, or at least its spark. Pause for a moment and reflect on the ground we've traversed. 3 Atlas, an extraterrestrial arrival. The third we verified. Yet unlike its predecessors, this visitor defies norms. It expels 150 kilograms per second without any backward push. Its density rivals a minor satellite squeezed into an area smaller than Manhattan. It emits nickel vapor at heats where the metal ought to solidify. Nickel tetracarbonyl, an artificial compound from industry, shows up in its light signature. The particles it disperses exhibit polarization so intense that experts suspected faulty equipment. It fails to spin, or if it does, its glow remains constant. It soaks up gigawatts from sunlight, yet feels frigid. And its path, its schedule, its synchronization with planetary orbits, all register as improbably precise, unsettling number crunchers. 7 irregularities in total, for potentially accountable, 3 stubbornly resistant despite mounting evidence. Add to that the disclosure, an unnamed message from an alleged European Space Agency colleague, outlining a team effort that couldn't align this entity with any familiar celestial form, detailing compounds unfit for an ancient stone, particles resembling engineered products, an energy ledger that refuses to add up, and a suppressed finding. Perhaps, after all, this defies classification as mere rubble. Enter the cue ball theory, a vast quantum relic from the universe's birth, a pocket of alternate rules cloaked in frost and grit, eroding gradually across eons. An inner power source independent of stars, yielding strange reactions as byproduct, venting evenly with ferocious force but no overall propulsion. It echoes tales from speculative fiction, yet according regarding the disclosure, it's the sole model that aligns every piece of evidence. The only scientific approach that transforms a collection of inconsistencies into a unified picture, and one that's verifiable. A couple of straightforward, testable forecasts. Observe the entity as it exits our solar system. If the emissions remain elevated regardless of how far it gets, that's the initial indicator. Direct a gamma-ray observatory toward it. Should a non-thermal, high-energy pattern appear, that's the follow-up clue. Observers will verify both within the next few months. Then consider the obscured phase. In 26 days, 3I/Atlas will slip behind the sun. Closest approach to the sun occurs on October 29th. An ideal window for any adjustments, assuming they're feasible. The prime chance to deploy scouting devices, if such tech is on board, and we'll miss the whole show. Not until December, when it reappears and we assess the path. Has it shifted? Did any alteration take place? Here's where the diversion hypothesis layers in more intrigue. Perhaps the comet serves as a smokescreen, flashy and conspicuous, pulling focus while true scouting unfolds nearer to our planet. The Galileo initiative is on alert for precisely that, with 3 sites surveying the heavens, hunting for a surge in bizarre occurrences near perihelion timing. If evidence emerges, the readings will capture it. Beneath it all, the research world is starting to crack. Not in public announcements or media spots, but in private discussions. Certain experts cling to the comet label, odd, yet earthly. Others examine the figures and find no harmony. The mental strain is turning into a career concern, per the disclosure, and the hush from key figures is amplifying. An initiative has surfaced, UNCIO, the United Nations body for interstellar objects, to streamline global efforts, employing the LOE metric as the standard gauge. Guidelines for swift action, monitoring arrays, and even vessels prepped for quick deployment when the subsequent intruder shows up, because another is inbound. The Vera-C. Rubin Observatory confirms as much. Interstellar visitors every few months, possibly more frequent, each representing a chance or an alert. Right now, 3i/Atlas scores a 6 on the LOE, sufficient to demand thorough scrutiny. Not quite enough to activate crisis measures. Yet should the forecasts pan out, if gamma rays surface, if the course alters, if the output endures, the score climbs, and debates intensify. We're on the cusp of discovery. Over the coming 3 months, or perhaps earlier, incoming info will either back the standard view or push us toward bolder ideas. Shots from Mars will clarify the core, whether vast or compact. Spectral analysis will sharpen the makeup details. Path readings in December will expose any solar occultation events. Gamma hunts will spot a trace or dismiss it. The Galileo effort will note any UAP upswing or come up empty. Come spring, as 3i/Atlas swings by Jupiter and Juno snaps detailed views, we'll hold a full spectrum of evidence to declare, assuredly, what this thing truly is, or at minimum, what it isn't. The cosmos speaks plainly. It can't conceal its enigmas indefinitely. If 3i/Atlas proves merely a comet, quirky but organic, the evidence will settle there. The oddities will clarify, theories will adapt, and will proceed. But if the info stubbornly resists, if fresh scans pile on more peculiarities, if the web of discrepancies endures and intensifies, we must pursue the implications. No matter how unsettling, no matter how it upends our assumptions about wanderers in the void. That's science's core vow. Not ease, not guarantees, but reality, no matter its odd shape. Thanks for tuning in, for sticking through this narrative's bends and thorny inquiries. If it resonated, tap that thumbs up. Sign up if you haven't. Your support counts big. Drop in the comments. Do you buy it's simply a comet? Or does something feel off? What's your take on this visitor? This clip aims for fun and learning. Opinions shared, particularly on the 4chan reveal and hypothetical ideas, aren't backed by mainstream science. Rely on vetted studies and agency updates for solid facts. Catch you next round. Keep eyes on the heavens, since entities are traversing the shadows. In mere months, we'll grasp a bit more on its nature. Night.